Hello and welcome to this new and first lecture of the new section on optimizing performance in this course, Mastering Generative AI. So in this particular lecture, in this particular section, we will give you an in-depth view of optimizing the performance. And in this particular lecture, we will start talking about how can you enhance the efficiency and performance of models, making sure that they run effectively and can generate content and quickly and accurately. So how do you think you can optimize performance? How can you enhance the efficiency and performance of these models that you have built and trained, right? Any thoughts? So doing that, enhancing the efficiency and performance of these models and ensuring that they run effectively and can generate content quickly and accurately involves several strategies and best practices. Now, what are they? Let's take a look at them. In summary here, and as we go forward, we will take a look at each of these. First, you need to optimize the model structure. Then you need to use efficient training techniques. Then you need to manage the data well, utilize hardware, uh, make sure that your model inference works well. You need to then fine tune and transfer learning, profile and monitor, and use the softwares and frameworks that can help you do some of these things, right? So that's all what you need to do. So let's start by looking at how to optimize the model architecture. So model architecture, optimization, you can do three things. One is what you can do is do model pruning, in which you remove redundant neurons and connections from the model. Basically, that will help you reduce its size and improve inference speed without significantly compromising the accuracy. So that is the one thing that you can do. Second thing you can do is quantization, in which you convert the model weights from floating point precision to lower precision. And we have talked about this earlier also. And specifically, example is from a 16 or 8-bit, uh, you can you can start using instead of 32-bit, 16-bit or 8-bit integers. Now, this reduces memory usage and speeds up the computation. Third thing you can do is knowledge distillation, in which you train a smaller model, a student model, to mimic the behavior of a larger and well-performing model, which is called a teacher model. This student model is more efficient while retaining similar performance. So these are the three ways to optimize model performance. So let's look at how to do model pruning. So optimizing a neural network model by removing redundant neurons and connections can definitely reduce its size and improve this inference speed without significantly compromising accuracy. And that is the purpose of model pruning. This is what is called model pruning. Now, what are the steps that you need to do and what are the things and methods you can use that are involved in this process? So let's look at the pruning methods. There are several pruning methods that can be applied to neural networks, and the most common ones are magnitude-based pruning, in which you remove neurons and connections based on their weight magnitudes. This assumption behind this is that smaller weights contribute less to the final outputs. The second thing you can do is a structured pruning. And in this technique, you remove entire neurons, filters or channels rather than individual connections. And this results in more efficient models as it aligns well with the hardware optimization. Third, you can do sensitivity-based pruning. Here, neurons or connections are pruned based on their sensitivity to the loss function, to 1 minus the objective function. And this method is more sophisticated as it considers the impact of the overall model performance. So you're pruning based on what is sensitive to the performance. Now, how can you implement this pruning? Now, involves following steps. You can start by training your neural network model to convergence, as you do in the training. Then you apply one of the pruning methods to remove redundant neurons and connections. And after pruning, the model typically needs to be fine-tuned to recover any lost accuracy. So these are the three steps that you need to do to implement the. So let us look at some of the examples in this slide with TensorFlow and next one Keras. So TensorFlow provides a built-in support for pruning through its TensorFlow model optimization toolkit. Now here are some basic example of how to apply tensor pruning. These are the codes that you import TensorFlow STF and then you take the optimization model and then you use this code to do that. So check both these codes out and see they're in sequence. So use these codes to see how well do that work for you. And here is the example with PyTorch. In PyTorch, pruning can be done using the torch.nn.utilis.prune module. And here is a simple example of the codes given here that you can use to do the pruning. So what do you do after that? After pruning, you can further optimize the model using the techniques such as quantization, where you reduce the precision of the weights and activation from float 32 to integer 8, and knowledge distillation, where you train a smaller student model to replicate the behavior of a larger proven successful teacher model. So by carefully applying these techniques, you can achieve a smaller and faster model while maintaining the acceptable accuracy levels. So what do we do next? So in the next one, we will look at the quantization. How can you do quantization to optimize the model? And that is the thing that we will discuss in the next lecture. So thank you so much for watching this first lecture on optimization performance. I hope you are continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question, and also download the PDF file to take a look at all those codes so that you can try for yourself and see whether they work for you as well.